Hey guys, Mr. Jenkins back here with what's going to be our last lesson of Chapter 6. So this is Section 6.6, and it's about systems of linear inequalities, right? So think about all we've learned this chapter. We've learned about how to solve systems of equations in various different ways by graphing, and we've leaned on Desmos a lot for that, by substitution and by elimination. Then did lots of word problems with systems of equations. And our last lesson was how do we graph these inequalities, right? What if we have an inequality symbol instead of an equals sign, and what all that looks like. So now we're going to add in systems of inequalities. So two or more inequalities and how that looks on a graph. Learning targets are we want to be able to solve systems of linear inequalities by graphing. It's really the only way to, quote, solve them. And then we want to do our word problem stuff, so model real-world situations. With that, let's jump right into example 1A. So first things first, how do we identify solutions of a system of inequalities? The answer to that is you do it the same way you would on a single inequality. You just sub in whatever the point is. So ours is, we want to know, does 212 fit this system? So we're going to sub in x is 2 and y is 12. And it's got to work for both. So in the top one, that would say 12 is greater than 2 times 2 instead of 2 times x plus 4. Is that true? The answer is, let's see, 12 is greater than, that'd be 4 plus 4 is 8. 12 is greater than 8, so that's a yes. Then it also has to work in the other one. So that'd be 12 is less than 3 times 2 plus 7. So that just says 12 is less than 6 plus 7 is 13. 12 is less than 13. So in this case, it works in both. So the answer would be a yes. So that's an example of how you check algebraically. Next, let's look at example B, example 1B, for how we would check graphically. All right, so my system here is 3x minus 2y less than or equal to 17. Notice I have that typed up here. And then 0.3x plus 4y is greater than 9. That is up there as well. And we want to know, is 8-2 a solution, right? So what is a solution to a system? The answer to that is where both boundary lines are shaded, right? So it's kind of hard to tell when you look at the screen, but we're shaded to the, let's call that the northeast part of this boundary line, and then, the northwest part of this boundary line, and then the northeast part of this boundary line. So we have some, but not both here, some, but not both here, no shading here. So this double shaded region is where it works for both, okay? So back to the original question, does 8-2 fall into that? Let's just see. So 8, 2, let me zoom actually in just a little bit. I'm a little zoomed out. All right, so 8-2, that's 5, 6, 7, 8. Here's 8-2. So the answer would be no, all right? It works for one of them, but not both of them, right? So if it would have said 8-4, that would be a yes. 8-2 is a no, all right, because it does not work in both. It works in one, but not the other. So that's what you would see if you plugged in to check algebraically, like we did on 1A. So that's a good segue into 1C. So this one says select all of the following. So these are all ordered pairs, which are solutions to this system. Okay, so let's just go point by point here. So 0, 0. 0, 0 is right here. That is in the double not shaded region. So that would be a no. I'm going to just X those out that are no's. -1, 0. So that would be right there. So that is a solution to this one, but it's not a solution to this one. So since it's not for both, that's a no as well. -5, 0. So that'd be 1, 2, 3, 4 over here somewhere. That would be in the double shaded region, which is this green part, which is the intersection of yellow in blue, right? So that would be a yes. -2, 0, that's where we get into the nitty-gritty details. That would actually be a no. It looks like a yes because it's right up against your double shaded region. But remember, things that are on a dotted boundary line are not part of the solution set. All right, so it appears to be in the shaded region for this one, but not for this one. Very close though, okay? -4, -3, so that'd be down here, so that'd be a yes. -2, -3, let's see, that'd be down here. It looks like that would be a yes too, because it's on that solid line and it's inside the double shaded region. So that's going to be a yes. 2, -8. So that goes way off our graph, but we know it's going to be down here somewhere. That definitely doesn't appear to be where the green would extend to. So that appears to be an obvious no. And then the last one, -10, -5. 10 to the left would be somewhere over here. Down 5 would be here. Okay, so even though we can't see it, you can tell if you projected that would be in the double shaded region. Okay, so that's a nice kind of tough question for you there. Moving on to the actual graphing of these. So it may say graph the system, it may say solve the system, both mean the same thing. All right, I did not mean to do that. All right, so I'm going to do A by hand and then use Desmos for B. You can do either one. All right, so if I'm going to graph this boundary line right here, well, I'll use X and Y intercept. That's what I'll do. All right, so on the top one, I am going to say that we're going to start at B is 0, -3. And if this stuff is not obvious, then you'll want to use Desmos. B is -3 and M is 2. We'll just go up to right 1. All right, and then we notice that it is not or equal to, so this one's going to be dashed. That's going to be a dashed line, not a solid boundary line. All right, so then where would we shade on that one? I can tell that we would shade below it because it says less than. So I am going to note that by just kind of making some arrows to indicate that. I just don't want my graph to be too sloppy, okay? And then our other boundary line, we're going to use intercepts. So my x-intercept is going to be 2 over 2, which is 1. So it goes through 1, 0. And my y-intercept is going to be 0, and then just 2 over 1 is 2. So it goes through 0, 2. I'm going to extend that a little bit. All right, and then that one is also dashed. And then where would we shade on this one? It says y is greater than, so we want to shade above. So that for this one to be above and to the right. So then your last thing is to decide where is the double shaded region. All right, so the 0, 0 test really is not going to work here because you have 1, 2, 3, 4 quadrants that could be it. So you really have to just be able to see it if you're doing it by hand, right? So my double shaded region is going to be right in here. Or you might say if we're divided into, 1, 2, 3, 4 quadrants, then we might say we're going to shade in the eastern quadrant. Okay, so there's a lot to these, obviously. If that was too much, then I suggest using Desmos. Okay, so let's look at example 2B using Desmos. So the first thing I would do is just go to desmos.com and type in my inequality. So y is greater than or equal to negative x plus 5. And then negative 3x plus y is less than or equal to negative 4. Okay? So we want to be very accurate when we are doing this, because you guys know Math Excel will not accept anything other than good accuracy. All right, so I'm looking at the red boundary line first. Notice that it is solid and it has a y-intercept of 0, 5 and x-intercept of 5, 0. So I would use just those 2 points right there. 5, 0 and 0, 5. And that just came straight from, Desmos. So 0, 5, 5, 0. And then I'm going to extend my solid boundary line through those 2 points. All right, so we've got the first one kind of on there. And I can tell that the shading is going to be above that, right? I'm not even going to mark that on my paper, but it is going to be above it. You can tell. And our blue one has, let's see, I'm gonna highlight the blue one and see if I can find any good points. So we have 0, negative 4, but then we have 1.333, comma 0. We can't really use that, okay? So we're gonna have to try to find another corner point. So I'm going to zoom in just a little bit. So it appears that it goes through 0, negative 4, and then goes up 3, right 1. So I'll just see if that works again. Up 3, right 1, up 3, right 1. So that appears to work. So I'm going to start at 0, negative 4, and I'm going to do a slope of up 3, right 1. 1, 2, 3, 4. So this was the obvious part, that it went through 0, negative 4. Then I had to do a little bit of thinking. That's the challenge when you're using Desmos, is if you don't get a good x and y intercept, you got to be able to ID the slope. Okay. All right, so I'm reminded that this one is also solid. So let me pull that up real quick. And look at that, my random point was right on the line. That was just an accident. Just dumb luck there. That's what I pretty much depend on these days, dumb luck. All right, so then where is the double shaded region? Obviously we have some shading here. Obviously we have some shading here. No shading there. But then you have to think a little bit to see that this is my double shaded region. Okay, so again, that's not directly obvious when you look at Desmos. All right, you do have to do a little bit of thinking on that. All right, so I'm going to leave C and D undone. Obviously, you can look at the filled out notes for those. And, with the fraction in there, that may be worth your while. All right, going into example 3, what if they now give us a system, or they give us the graph of a system and they tell us to actually write the system, okay? So these are going to be tough if you never got really good at writing the equation of a line, all right? If you can't look at a line and identify what M and B are, you're just going to struggle with this, all right? So I don't know what else to tell you other than that. So I'll let this first boundary line be number 1, okay? So we want to identify B. So B is like -1. And then my slope is going to be, let's just pick a point that's kind of far away from it. Slope between those 2 points would be up 3, right 3, which is just 1. Okay, you might have just seen it went up 1, right 1. All right, so if the slope is 1 and B is -1, then I know that this one is y is blank instead of equals 1x, or x minus 1. All right, so because it is solid, it's going to be or equal to, okay, or equal to. So then is it less than or equal to, or greater than or equal to? So the answer to that is going to be, so it appears to be below the red line, and then above the solid line, the solid blue line, above would mean greater than. So overall, y is greater than or equal to x minus 1. Like I said, not really that easy on these. Okay, looking at the second one, the other boundary line, we have B is 1, 2, 3, 4, 5. So B equals 5. And then M is, let's see, if we go from that point to there, we go down 1, right 2. So -1 over +2 would just be -1/2. So we have y is blank, then -12x plus 5. So now deciding what our inequality symbol is, since it's dashed, it's not going to have or equal to. So is it strictly less than or strictly greater than? So again, we're going below this line, so that would be less than. So final answer to this is y is greater than or equal to x minus 1. Y is less than -12x plus 5. All right, I'm going to skip the other one. It is done on the filled out notes. I assume you guys will want to see that one on your homework. So, ask away is what I would say about that. And then our last type of examples are going to be these word problems. I'm going to, as far as the graphs go, I'm going to be leaning on Desmos because each of these have kind of 3 restrictions in there. So in order to save us a little time, we'll use some Desmos. Okay, so the key will be then your ability to take the verbal phrases and turn them into inequalities. Okay, so let's start by just reading the prompt. It says, you are planning what to do after school. You can spend at most 6 hours daily playing basketball and doing homework. You want to spend less than 2 hours playing basketball. You must spend at least an hour and a half on homework. What's basically a graph that shows all of this. So I think it's still important to always define your variables. So I'm going to call that step 1. We want to use x and y here. All right. So it matches with my notes. It doesn't matter which one's x and which one's y, but just so it matches what I've already typed into Desmos, I'm going to say x is homework time, y is basketball time. All right, so based on that, let's start writing some inequalities. So here it says you can spend at most 6 hours doing both. All right, so at most would mean less than or equal to. So that would be x plus y, that would be both, is less than or equal to 6. So that's one of my inequalities. The next one, it says you want to spend less than 2 hours playing basketball. All right, so y is basketball. So we'll say y is less than 2. So that one was pretty easy because it said it directly. And then lastly, we have you must spend at least, so that'd be greater than or equal to 1.5 hours on homework. So we'll say x is greater than or equal to 1.5. So that's obviously the key, coming up with this and this and this, right? Once you do, then we'll use Desmos, so we don't have to think about each little part individually. And most important, here we'd be looking for a triple shaded region. All right, so I'm looking for 4A here. All right, so we've got a lot going on. Notice on my paper, all I have is a first quadrant graph. All right. So really all I care about is in this region right here. So that's what I'm going to look at. Okay. All right. So let's just go, line by line. So one of mine has 0, 6, and 6, 0. So that would be this one right here. So it goes through 0, 6, goes through 6, 0. Also, it is solid, and it looks like we shade below it. It is solid, and we shade below it. So again, I want to try to be as neat as I can be. Actually, we'll talk about shading at the end since we have it pulled up on Desmos. I wanted to just maybe focus on the boundary lines first. So then we have another that, click on this dash line here. And oh, there we go. All right, so this other one is a horizontal line that goes through 0, 2. So that's obviously going to be this guy right here, and it looks like we are shading. Where are we shading on that one? It looks like we're shading below it. All right, so below that one. Again, I want this to be dashed. Sorry about all the lag there. All right, and then the last one is going to be this guy right here, the blue one. Looks like it goes through 1.5, 0, and is vertical. It's also solid. So vertical solid line that goes through 1.5, 0. All right, so the last thing we want to do is figure out where is the kind of triple shaded area. All right, so just to recap, we went to the right of this one. We went below this one and below this one, right? So where is it triple shaded? And it's really, really hard to tell, but it is actually triple shaded right in here, okay? Because note it, why is that tough? Because, we have, let's see, 1, 2, 3, 4, 5, 6, 7 options to choose from, So it's not really easy and obvious to choose. The only one that's obvious would be, this one back here. That's the only one that doesn't have shading in it at all on our screen. So I'm going to give you a tip on the next example on how to make it more obvious where your triple shaded region would be. All right, so let's do one more. Bear with me. And actually, we'll just get to I'm going to skip the word part problem of it, and you guys will just take my word on these are your inequalities. I do encourage you to read through it on your own and think about how I developed this stuff, but, I want to just save some time as well. All right, so we're going to say in this problem, X is lawn care, time spent doing lawn care, and then Y is time spent at the store. So then you have your boundary inequalities are going to be x plus y is less than or equal to 35. Another one is going to be 12x plus 10y is greater than or equal to 350. And then your last one is y is greater than or equal to 10. So hopefully all that pops up here soon. There we go. And so watch what I did in Desmos, okay? This is the key that I wanted you to focus on for this last one. How can we tell, again, not only how to graph the boundary lines, but also make it easier to find that, triple shaded region. So let's focus on the boundary lines first, and then I'll come back to the shading. And you may notice something that I did wrong, and I did that intentionally. So anyways, looking at this line, we have 35, 0, and 0, 35. That's easy enough. So there's 0, 35. There's 35, 0. It is also solid, and I'm not going to worry about shading until the end. Bear with me here. There we go. All right, so got that one on there. Now let's look at this other one that's kind of close to it. Red line. So we have, it's like right at 29, comma 0, and 0, 35. So same y-intercept as the other one, but it goes to about 29, comma 0. So that's 30 right there. So I'll just put my x-intercept right there. And go from there up to the same y-intercept as the other line. All right, so that gives us that flashlight kind of looking part of it. And then the last one is going to be a horizontal line that goes through 0, 10. It is solid as well. So there's 0, 10. I'm just going to keep it on my line tool here. See if that'll come up like I wanted it to there. Might have to do that again. There we go. All right, so the key to all this, the only reason I showed this other one is a trick for shading, okay? So you might notice that, look, Mr. Jenkins, this says x plus y is less than or equal to 35. I typed greater than or equal to 35. That says greater than or equal to 350. I did the opposite, less than or equal to 350. I did the same thing here. Our inequality is y is greater than or equal to 10. I type the opposite. So what happens is if you do all the opposite, your triple shaded region is actually the one region that's going to be empty. So it's going to be that little part of the headlight. So that helps me to see visually that really this is my triple shaded part. Okay. Without doing it that way, it's really, really hard to tell. Okay. So anyways, with this graph, we could tell all the combinations we could do, anything that's in the shaded region. So, just as an example, throwing out a random example, it looks like, 20 comma, say 12 is in there, 20 comma 12. So that would mean I can do 20 hours at lawn care, 12 at the store, right? So that's basically what that graph tells you. Anyways, obviously a lot to this lesson as well. So hopefully it helps. Hopefully you guys continue to do your job and watch the videos and then try the work and ask questions along the way. That's all we have. That brings us to the end of the chapter. So at this point, we will start to kind of review and get ready for our next eventual test, which will be chapter 6. Thanks. Have a good one.